Hello and welcome to PreCalc Lesson 5. We have a ton of stuff to cover today, including exponents and radicals, complex numbers, areas of similar geometric figures, diagonals of rectangular solids. Woo! So let's jump right into it. We have the square root of x cubed y times the fourth root of xy cubed. Our first step is going to be to get rid of the square roots and replace them with powers. So a square root is to the 1/2 power, and the fourth root is to the 1/4 power. So now I'm going to distribute these. I have x to the 3/2, y to the 1/2, x to the 1/4, y to the 3/4. Then I'm going to combine like terms. So x to the 3/2 times x to the 1/4, 3/2 plus 1/4 is 7/4. 1/2 plus 3/4 is 5/4. And that's your answer. Big step here, converting the square roots to the powers. Next, we are going to do a much uglier problem. A to the x over 2, y to the 2 minus x to the 1/2, all over a to the 3x, y to the negative 2x. First step, I'm going to distribute this exponent. So I have a to the x over 2, and also I'm going to bring these things up because I want it all in the numerator so it looks nice and sharp. As I distribute these, I have y to the 1, 2 divided by 2 is 1, minus x over 2. It's a little gross. I'm going to bring the a to the top, so I have a to the negative 3x, and bring this to the top, so y to the 2x. Now I'm going to combine the a terms. I have a to the x over 2, a to the negative 3x. 1/2 minus 3 is negative 5/2. Now I have y, I have 1, now I have negative 1/2 plus 2. Remember that, let's just do a little side here. This is the same as, right? Don't let the x's scare you. This is a simple fraction problem. Negative 1/2 plus 2. So what is negative 1/2 plus 2? Well, 2 is 4/2. So 4 minus 1 is 3. So plus 3/2 x. And that's your answer. This is really just an exercise in you being diligent about keeping track of your minus signs and really paying close attention to what you're doing here. Okay. Next, this one always gets students because they want to flip things from the top and bottom. You are never allowed to flip to the top and bottom if you have addition like that. Okay, so you have to evaluate it in place. If you just had x to the negative 2 and were asked to simplify it, let's say in algebra, you would write 1 over x squared. If you had y to the negative 2 and you were asked to simplify it in algebra, you would write 1 over y squared. And so that's how we're going to simplify the top. Unfortunately, it makes it more complicated. On the bottom, xy to the negative 1, I could bring it to the top right away, but I'm going to do the same thing here. So this is only when you have addition here. Otherwise, bring everything to the top right away. These were all multiplication and division. That's fine. Here we have addition and it throws everything off. So now I have to add these fractions first, which is a little bit annoying, but we can endure. So I need a common denominator here. And that gets me y squared plus x squared over x squared y squared all over 1 over xy. Always make your middle one really long so that you know that that's the middle fraction mark. My last step is I'm going to multiply by xy on the top and bottom. Those cancel with those. And I'm left with y squared plus x squared over xy. It's not bad, but most students forget that first step and then cannot recover. Flipping the page. All right, so now we have some square roots that we get to deal with. So we have 3 square root of 3 over 2 minus 4 square root of 2 over 3 plus 2 square root of 24. Our first step is to get rid of the square roots in the denominator. How do I do that? Well, since they're fractions, I can multiply the top and bottom by the same thing. So I'm going to multiply by whatever square root is in the denominator. So that gives me 3 square root of 6, because 3 times 2 is 6, over 2, minus 4 square root of 6 over 3, plus 2 square root of 24. Now I'm going to try and add these by giving them all a common denominator. So it looks like 6 would be my common denominator. So I'm going to multiply this one by 3, multiply this one by 2, multiply this one by 6. Oftentimes students miss multiplying the last one by the common denominator, and that's usually where things go wrong. So here I have 9 square root of 6 minus 8 square root of 6 plus 12 square root of 24 all over 6. So I can combine these two, but not this one. Let's see if we can work on this. The square root of 24 is the square root of 4 times the square root of 6. So I can simplify that one, and then all of these are in terms of square root of 6. Now don't expect this always to be the case as it was in Algebra 2. You're in pre-calc now. The numbers are a little bit more challenging, okay? So 9 minus 8 is 1, plus 24 is 25. So this is 25 square root of 6 over 6. Woo! All right, moving on. Your life is about to get more complex. I love complex numbers because it's a great picture of the physical realm and the spiritual realm, right? Like up to like somewhere around Algebra 1 and Algebra 2, you're like blissfully unaware of I and whatever the square root of -1 is and complex numbers. And then your eyes are opened and you see that there's all these other possibilities. In the same way, I think a lot of people are just blind to the spiritual realm. They don't see God moving. They don't see the hand of God on their everyday life. They don't see the hand of God in creation. But if you look for it, if your eyes are open to it, oh man, you see amazing things that the Lord has given us. So we remember, and this table should be in your notes, that I is the square root of -1. If we square that, we have the square root of -1 times the square root of -1, which is -1. Okay, any square root times itself is just that number inside. I cubed is -1 times I, or -I. And I to the 4th is 1, because we have -I times I. Now, the pattern continues. So if you have an I to the 5th, that's I again. I to the 6th is -1. I to the 7th is -I. I to the 8th is 1. And then it will repeat over and over and over again. So, if you have problems with higher powers of I, then that's what you will need. So let us, not the vegetable, do this problem. We have 3i cubed plus 2i to the 5th minus 3i plus 2i squared. Your first step is going to be to get rid of the i's, or at least simplify them down using this table. So I have 3i cubed is -I, plus 2i to the 5th is I. I always put them in, I always put them in parentheses just so I know that I plugged in. I squared is -1. Now from there, I'm going to add like terms. Our answer should always be real part plus imaginary part. That's how we write complex numbers. So that has an I, that has an I, that has an I. So this is going to be my first part, -2. And I have -3 plus 2, which is -1, minus 3 is -4. Right. That's your answer. Real part goes first, imaginary part goes second. If you do not do that, you will lose points. Alrighty. Now, let's move on to this one. These are often confusing because students try and skip a lot of steps and then mess up and then have no clue what went wrong. So, I would highly encourage you not to skip steps and instead to show your work on these. I know I told you earlier that you could get away with skipping a lot of steps. This is not the case. So your first step is going to be to deal with all the i's before you multiply, before you get rid of square roots and all of that. So every time I see a minus inside a square root, I have an I. So this term will have an I in it. This term will have I squared. This term will have an I. Now I'm just going to copy everything down. Now I can evaluate as much as possible. So the square root of 4 is 2. I know that I squared is -1, so I'm going to deal with that. Square root of 9 is 3. 3 times 3 is 9. Square root of 2. Plus the square root of 16 is 4. Plus 4. Now, here I'm going to combine all the real parts. So I have 4 minus 9 square root of 2. Again, you have your real part first with no i's. Plus, now I'm going to get all the I parts and combine those. And that's that. Now, we have 2 pieces left. This part is a part that unfortunately most students forget and then miss points on a test because it's so easy that you can't miss it. Okay, if I have a square of radius 1, or of side length 1, and I have a square of side length 4, what's the ratio of their areas? Well, the ratio of the sides, side 1 divided by side 2, is 1 over 4. The ratio of their areas, well, let's just compute. The area of this square is 1, the area of this square is 16. So area 1 divided by area 2 is 1 over 16. What's the relationship? Well, it's the ratio of the sides squared. So if they say these two are similar and the scale factor, or how you get from one to the other, is 4, then you know that their area factor is 4 squared, or 16. Okay? So all you have to do, they're going to give you the scale factor. So the scale factor between 2 squares is 4. What is the ratio of their areas? And that's it. So you're going to square the 4 because you're doing area and not just the size. Simple concept when you have good concrete numbers. Usually they'll say like you have a 100-sided polygon and they're similar. So you can't draw it out. You just have to remember that they're squared. Last thing is we are going to do the diagonal of a 3-dimensional shape. So basically we're doing 3D distances now. So we're going to do the distance from this point down here to this point up here. How do we do that? Well, it's actually pretty easy. Let's call this A, B, and C. Our normal distance equation was x2 minus x1 squared plus y2 minus y1 squared. But if we add the z dimension, or the up, we would add plus z2 minus z1 squared. So the equation I want you guys to write down, it's actually really easy. The distance from here to there is simply a squared plus b squared plus c squared, all under a square root. So if we put numbers to this, I can find the distance across this right rectangular solid, because it's 1 squared plus 2 squared plus 3 squared, that looks like 10, 14. It's the square root of 14. And that, my friends, is problem set 5. Woo!